Greetings, pre-calc students. In case you thought about inviting me to Panera for your study group, I'm sorry I couldn't make it, so I made this video instead. Studying with Mrs. D, Trigonometry, Chapter 4a. So here are the commonly asked questions. I'm just trying to anticipate since, again, I can't be there with you. The first question people usually ask me about is number 5. Cosine inverse of cosine of negative pi over 7. And generally, what they're kind of freaking out about is the angle, first of all, realizing that angle isn't so special, but I'm just going to try to visualize a little bit here. Negative pi over 7 is probably close to negative pi over 6, so I'll say it's right about there, terminating in quadrant 4 somewhere. And regardless of knowing this ratio, that ratio will lead us to an inverse of that ratio, which kind of brings us to an angle. The question then becomes, what angle is it? Well, if you don't know the ratio, maybe it's hard to figure out. But actually, this question really becomes more about reference angles. So first and foremost, the common wrong answer is negative pi over 7. And that would be wrong because you need to give an angle between 0 and pi. That's the restriction for cosine inverse, remember? So negative pi over 7 does not fit that bill. And now we have to think about references. Well, could it be positive pi over 7? I could draw the same triangle, of course. But I would probably give that yes! Actually, I think it will, right? This angle, whatever that position is, the positive pi over 7 has the same exact x value, which would be the same cosine ratio. Yay! So I have found it. The answer to this question is pi over 7. That angle is between pi and 0, and it has the same exact cosine ratio as negative pi over 7. Done. This next problem is confusing because of the arbitrariness that x is some unknown ratio. And again, we're trying to find the angle. Maybe we can't find it though, so let's try to picture it. If I picture it, maybe in a triangle format here, this unknown angle, I'll call it theta. The x is the cosine ratio. That relates the adjacent and the hypotenuse, right? So the adjacent side must be x, obviously unknown, but we can always write any ratio like that over 1, so that would mean our hypotenuse is 1. Pythagorean's theorem real quick would help us to express that third side, and b squared would be 1 minus x squared, so b would actually be the square root of that. Notice I didn't square root the 1 and the x squared. I can't do that. I won't. And we end with a ratio here. I'm picturing my angle. The final answer here should be the tangent ratio of that angle. So relative to that angle, the opposite side is square root of 1 minus x squared. The adjacent side is 1. And that's the end of that story. We have found the tangent ratio for the unknown angle with the unknown sides. And basically we just wrote it in an arbitrary way. This problem is interesting to people because there's an interval here, and they're like, what? What's that for? And I'm telling you that you're trying to find the value of x within this given domain. So if I give you this range of numbers, I guess, you're trying to find x, which is some angle, obviously. I hope that's obvious. It's an angle measured in radians between 0 and pi. I'll picture it on my unit circle. We're looking here. And I know that's counterintuitive. Tangent inverse, your teacher probably taught you. The range of that function should be between negative pi over 2 and pi over 2. But for this one, we're going to go with the given information. So there's some unknown angle. The tangent ratio is negative square root of 3. Now, if you really don't understand this in the unit circle, let me try to draw a triangle that would show it nicely to the best of my drawing abilities. I am given the opposite side, and the adjacent side, let's say, is 1. This would not be on the unit circle, of course, because the hypotenuse here is 2, but you get the point that this is pretty special. I think it's some reference to 30, 60, or 90. probably 30 or 60. Well, I'm going to go to the unit circle because I really like it a lot. And I'm going to pick an angle not in quadrant 1 because everything's positive there, tangent included. I'm going to draw a triangle here in quadrant 2. And perhaps it will be this triangle with a negative 1/2 positive square root of 3 over 2 position on the unit circle, right? Radius of 1. So this angle, I feel like, will be giving me my answer. And which angle is that? Because that opposite side, just to confirm for myself, divided by the adjacent side, would simplify to a negative square root of 3 over 1. So that's my angle. It's a reference to 60. In the world of radians, that angle is 2 pi over 3. Pi over 3 would be 60 itself, but again, that has a tangent ratio of positive square root of 3. Not the angle I'm looking for. So 2 pi over 3 it is. This is where the fun begins, actually. The two word problems people usually ask about are this radial saw problem, which to me, as I look at it, I think about what topic we are working on here, and this seems to be just about conversion and rotation or circumference. So, in the spirit of conversion, I'm going to have some facts lined up here. The windshield wiper problem actually is, while we're talking about planning, this is not really a problem about conversion, more so it's a problem about arc length, or the idea of a portion of a circle. Really, it's not a portion of the circle's length or circumference, but area. We'll get to that in a second. So the radial saw. Actually, the first fact that jumps out to me is the 2000 RPM, and R stands for revolutions here. M is for minutes. And I can quite easily start changing that into seconds. So I'm going to convert the time element here, multiplying by the fact that there's 1 minute for every 60 seconds. I currently will have revolutions per second. And then I'm going to try to start working towards teeth. What? That's weird. How do I get to teeth from this? Well, teeth, I know how many there are per inch. Maybe I should get to inches, actually. Let's do that. So every revolution, like one time around, whoop, there's a revolution. Whoop, another revolution. Here's another revolution. Every revolution has a certain number of inches that it travels, and that's based on the diameter. So I will call this exactly 10 pi inches. And that's based on circumference being 2 pi r, or some people call it pi times diameter, because 2 radius is equivalent to 1 diameter. Now I'm almost done here. If I use all of these calculations and multiply and divide accordingly, I have inches per second. The very last fact I will use is that there are 12 teeth per inch of this saw blade, and then the inches will undo. So if I multiply 12 by 10 pi by 2000, lastly divide by 60, I should get a nice large number of 12,560 teeth per second. Wow. That's how saws work. They move really fast to cut through the wood, and that's how they do it. 12,560 teeth cutting through that wood per second. Ta-da!